Now we're ready for the next problem. Looks like problem 47. Instructions are: solve the equation, give the general formula for all solutions, list 6 solutions. So we're going to solve this equation, but we're going to give the general solution. So once again, the goal for this is not to teach it, but just to work out these problems. So let's go ahead and do that. So here, I'm looking look at the unit circle, and I say, let me go find an angle where the sine is negative square root of 3 over 2. And it turns out in quadrant 3, I look 4 pi over 3, the sine of 4 pi over 3 is negative square root of 3 over 2. But the general solution says I have to add the 2 pi k. But in going around the unit circle, there's another angle, 5 pi over 3. The sine of 5 pi over 3 is also negative square root of 3 over 2. So there are two general solutions. So in these answer blanks, let's see what they say. Write the general formula for all the solutions based on the smaller angle. So 4 pi over 3 is smaller than 5 pi over 3. So the first answer is going to be 4 pi over 3 plus 2 pi k. And here they want to write the general formula with the larger angle. So that's 5 pi over 3 plus 2 pi k. Now they say list the first 6 solutions that are all greater than or equal to 0. So the way I like to do that, what I think is the easiest, is I take, here are my two general solutions. I'm going to start plugging in values of k, and then I see what my solutions are going to be. In other words, I start with k equal to 0, because k is going to be 0 and 1 and 2, then 3, and it can also be negative. K can be negative 1, but I think here in the answer it wants the angles to be between 0 and 2 pi. So I'm not going to use any negative numbers for k. So here we go. So they want the first 6 answers. So when k is 0, when I plug in 0 into this first general equation, I end up with 4 pi over 3. And when I plug in 0 into the second general equation, I get 5 pi over 3. So those are going to be my first 2 solutions in a minute, which I'm going to plug in this last answer. Here are the first 6 solutions that are greater than or equal to 0. I guess I can plug in these first 2. 4 pi over 3, 5 pi over 3. Now let's bump k up to 1. So when I plug in 1 into my first general solution, I have 4 pi over 3 plus 2 pi. So I have to do a little bit of math here. Well, 2 pi with the denominator 3 is really 6 pi over 3. So 4 pi over 3 plus 6 pi over 3 is 10 pi over 3. And if I plug in 1 for this k, I get 5 pi over 3 plus 2 pi, which is going to be 5 pi over 3 plus 6 pi over 3. That's 11 pi over 3. So now here are my next 2 solutions. 10 pi over 3 and 11 pi over 3. So there's 4. I have to get 2 more, so let's set k equal to 2. When I put a 2 in for k here, 4 pi over 3 plus 4 pi. 4 pi over 3 plus 4 pi. Of course, 4 pi, if I convert to a denominator 3, so let's multiply top and the bottom by 3. It's 12 pi over 3, so 4 pi over 3 plus 12 pi over 3 is 16 pi over 3. And when I put 2 in for this one, I get 5 pi over 3 plus 2 pi. Sorry, when I plug a 2 in here, it's 5 pi over 3 plus 4 pi. Well, 4 pi I know is 12 pi over 3, so that's 17 pi over 3. So there are my next 2 solutions, which I plug in here. 16 pi over 3 and 17 pi over 3. So those are the actual first 6 solutions. And that is correct. So there's a problem where you're solving the equation and they want the general solution. Now for the rest of these, I think they're going to now start asking for what I call the specific solution. Usually they like to look for solutions between 0 and 2 pi. So for instance, this next one, so look here, solve the equation on interval 0 to 2 pi. So they're looking for the answers that are 0 and less 0, greater than equal to 0 and less than 2 pi. So it's a 2-step process here. First of all, we want to solve for the trig function. We get the cosine of theta by itself. So I'm going to add 1 to both sides. If I want to get cosine theta by itself, I'll divide both sides by 2. So now I've solved for the trig function. Now in this case, the actual goal of the problem, theta is like your variable. We want to solve for theta. That's what the solution set is. What does theta equal? So then you say, okay, one trip around the unit circle, what are the angles? The angle or angles where the cosine is 1/2. Since I have memorized the unit circle, I say it's pi over 3. Let me write this down, then I'll show it to you. And 5 pi over 3. So pi over 3, cosine's 1/2. The other place in the circle is 5 pi over 3, the cosine's 1/2. So then those are your 2 solutions. You would put these in this box. I will confirm that's the correct answer, and that is. So the next one, solve the equation once again, looking at between 0 and 2 pi. 4 sine squared theta minus 1. A little trickier, we got a sine squared. Let's go ahead and get the sine squared by itself. So I'm going to add 1 to both sides. If I want to get the sine squared by itself, I'll divide both sides by 4. Now, the first step to solve this is to solve for the trig function, which means I want to get to sine of theta. So this is more of an algebra question. How do I get from sine squared to sine? Well, what you do is, if you take the square root of something squared, you just are left with what's inside. But of course, I have to take square root of both sides. Now square root of 1/4, square root of 1 is 1, square root of 4 is 2. But, very important now, whenever you take the square root of a number, there are actually two solutions, a positive 1/2 and a negative 1/2. So really now, you need to think of it like this. I've sort of got two equations to solve. I need to go once around the unit circle and find the angles where the sine is 1/2, and then turn around and find the angles where the sine is negative 1/2. Well, the angles where the sine is a positive 1/2, I'll write it here because I know the answer, and I'll show you on the unit circle. So 1/2 is pi over 6 and 5 pi over 6. So look at where the sine is positive 1/2, here at pi over 6, and here at 5 pi over 6. But also now, I need to find the angles where the sine is negative 1/2, and that occurs at 7 pi over 6 and 11 pi over 6. So now where's the sine negative 1/2? Right here, 7 pi over 6. And where's the sine negative 1/2? 11 pi over 6. So actually there are 4 angles for the solution. All right, now it starts to get a little tricky because the big thing about this one, up until now, if you look inside the trig functions, inside the trig function is just angle theta. Now we've got a bunch of stuff inside the trig function. In this case, cosine 2 pi minus 2 theta minus pi over 2. Let me actually write this out so I have room to solve it. And you notice it still wants the solutions between 0 and 2 pi. So here's how we have to solve this problem. The way I like to do it is, you can imagine me sort of initially ignoring what's inside the cosine function, and I'm just saying the cosine of what angle equals 1. So what are the angles on the unit circle where the cosine is 1? Well, that occurs when for angle 0, and that's all. Well, no, I'm trying to think. Just to be safe, let's go ahead and also put just to be safe, let's include 2 pi and see what happens. Sorry, I should have put, we're trying to solve for theta. So once again, I look up here and I see, and I ask myself, what are the angles where the cosine theta equals 1? 0 and 2 pi. But of course, I don't have theta in here, I have this. So therefore, matter of fact, to make it simpler, we'll just write it twice. And of course, okay, so now when I write this out, I need to write out the general solution. And I realize when I do the general solution, when k is 1, it's going to be 2 pi. So as it turns out, I don't need the second equation. So it's a little messy. So here's what I have now. Two theta minus pi over 2 equals 2 pi k. I need to now solve this equation for theta, get theta by itself. First thing I'll do is add pi over 2 to both sides. I need to get rid of this 2 or move it to the side, divide both sides by 2. So everything on both sides gets divided by 2. And you end up with pi k, these 2's cancel. This 2 goes up here. So this is now what we would call my general solution. So now I do what I always do. I start putting in values of k, and I'm looking for all the answers for theta that are between 0 and 2 pi. So if I put in 0 for k, I get pi over 4. That's a solution because it's between 0 and 2 pi. If I put in 1 for k, so pi plus pi over 4. Well, pi is the same thing as 4 pi over 4. So 4 pi over 4 plus pi over 4 is 5 pi over 4. That's between 0 and 2 pi. Now if I put in 2, well, you notice right away I put in 2 for k. It's 2 pi plus pi over 4. That's going to give me an angle theta larger than 2 pi, which I don't want. So I can now stop. And it looks like those should be my two solutions. So once again, let me check. This is problem number 50. And the answer is pi over 4 and 5 pi over 4. Let's look at the next one. Actually, it looks a little messier, but it's actually not that hard. You see here it's in parentheses cotangent of theta minus 1 times in parentheses cosecant of theta plus 1 equals 0. If you think about algebra, the solution is going to be whatever value for theta would cause this parenthesis to equal 0, or whatever value for theta would cause this parenthesis to equal 0. If either of these parentheses equals 0, 0 times anything is going to be 0. So to find my solutions, I take this first parenthesis and I solve this equation. And I also take the second parenthesis. So I solve both these equations for theta, and then I look at all the possible solutions between 0 and 2 pi. So for this one, let's get the trig function by itself. Add 1 to both sides. Now when I'm trying to solve this, I don't like to work with cotangent. Let me switch this to tangent. But remember, let me write it this way. Nope, sorry. So if the cotangent's 1, I put a 1 in here. This is the same thing as saying tangent of theta is 1. So in a minute, I'm going to solve this. Let's do the same thing here. So if I get cosecant by itself, subtract 1 from both sides. Now for cosecant, let me just do this so I have room. Cosecant is grouped with the sine, so the sine of theta is 1 over the cosecant of theta. So if the cosecant of theta is -1, you put in a -1 here, and you get sine of theta is -1. So this is the same thing as saying the sine of theta equals -1. So let's look at tangent of theta equals 1. Going one trip around the unit circle, what are the angles where the tangent's 1? Where the tangent is sine over cosine, so I need to find the angles where the sine and the cosine are identical. Both numbers and the positive and negative. Look here. Cosine, sine are the same thing. That happens at pi over 4. Go to the third quadrant, cosine and sine are identical. So it looks like pi over 4 and 5 pi over 4. So those are the two solutions I get from this. Now I look at this one, and this says, so what's the angle where the sine's -1? And that only occurs at one place, and that's 3 pi over 2. So it looks like there are 3 angles that are the solutions to this problem. And those are the correct answers. All right, let's see what we have next. Okay, next we start working with inverse trig functions. So let's stop for now, and we will continue with the next video.